So this is question 5. We've got a diagram, we've got a curve, an equation, we've got a region for the curve, and it tells us for the region bounded by x is 1, x equals a, y equals 0, which is the x-axis, and the curve. We're told a is a constant greater than 1, and we know the area is 16, and we've got to find a. That's the first part of the question. So we're integrating between left-hand limit of 1, the right-hand limit of a. We're integrating our function, which is 6 over the square root of 3x minus 2, and we know the answer is 16. So what we've got to find is a, this limit. So the first thing you can do is think about how can you rewrite this integral. Well, you can certainly take the 6 through the integral sign, as it's just a number. That's my a. And this 3x minus 2 is being square rooted, and it's on the bottom of the fraction. So I can put a half in for square root and a minus power as it's on the bottom. And I get that's equal to 16. So if I do the integration, I have my bracket. I have to add 1 to the power on the bracket. I have to divide by that new power and divide by the derivative of the bracket, which is at 3. So if I do my integration between my limits of 1 and a, I've got my 6 there and my 16 over here. Now what I can do is I can move some things around. I will keep this 3x minus 2, the power of a half, which means square rooting, inside the rectangular brackets with the limits. Keep my 16 over here. I can move this 6, it's just a number, timesing on one side to dividing on the other side. A half of 3 is 1 and a half, and it's dividing over here, and I can take it over here and multiply. Then I can work this out over here. I can do some cancelling down, whatever you like. 3 goes into that once and into that twice. 2 goes into that once and into that 8 times. So I've got 8 over 2, I've got 4. And over here, I've got 3a minus 2 being square rooted. And when I put x is 1 in, I get 3 lots of 1, which is 3. Take away 2, which is 1, square rooted, and that equals 4. Well, this is just 1, and I can add 1 to both sides. If I then square both sides, add 2 to both sides, and divide both sides by 3, I get that a equals 9. So I found the missing a, which is the first thing I had to do in this question. The second part of the question is asking for a volume of revolution of this region A rotated around the x-axis. So a volume of revolution is pi y squared dx if you're looking to rotate around the x-axis. My limits will be 1 and a. Now y is the function we're dealing with, which is 6 over the square root of 3x minus 2 square rooted. So y squared will be this whole thing here squared. And if you square a fraction, you can square the top and you can square the bottom. So squaring the top, you get 36. Squaring the bottom just removes the square root sign. So I'm integrating between 1 and a, and I can take my pi outside. 36 over 3x minus 2 with respect to x. If you're integrating a fraction, one thing I always suggest you look at is the top of the fraction the derivative of the bottom? Well, not quite. But if on my bottom of my fraction is 3x minus 2, the derivative of that is 3. Now if I put a 3 there, what I've done is I've just divided this whole thing here by 12. It was 36 and now it's 3, so I've divided it by 12. To make up for that dividing by 12, I need to times by 12, and I can do that outside of my integral sign. These two integrals here are equal, and the top now is the derivative of the bottom. And if you're integrating a fraction where you have a function on the bottom and the derivative of that function at the top, the derivative is log of the function on the bottom plus a constant. So from that line up here, I can keep my 12 pi, and the integral is log of 3x minus 2. Now the limits I need in this question were 1 and 9, so I can put those in. Now it's a case of evaluating this. So I'll have my 12 pi. When I put 9 in here, 3 9s are 27, take away 2 is 25. When I put 1 in here, 3 ones are 3, take away 2 is 1. So I've got 12 pi into log 25 minus log 1. Log 1 is 0, so I'm just left with 12 pi into log 25. And that's the exact value, the answer to this question. And it says an exact volume, so I don't want you to work it out as a decimal. They wish you to leave it in that exact form.